Alex Wagner, lead data scientist slash sales engineer at the startup SeerAI. Welcome on the Geospatial Index.
Well, pleasure to be here. Thanks for having us.
What is the elevator pitch for SeerAI?
So I knew this question was coming. I was thinking of what the elevator pitch would be, and my real answer was if we were in the elevator, I'd probably hit the emergency button so the elevator would stop and we could actually chat for a while. But since we can't do that, the elevator pitch, I think, is if you could redo data management from the perspective of geospatial, incorporate that in, what would that look like? And while we don't have it perfect, I think it would look a lot like what we've built. And if you're talking about where the insertions are for geospatial, and in our case, spatial temporal, you would say we would probably change how we connect to data, analyze that data, and share that data out. And really, we would probably remove a bunch of the big heavy lift of geospatial data, what you have to do with that. Anybody that's tried to deal with satellite data or huge rasters or imagery data or whatever, it is a heavy lift. So if you could redo it from the beginning and remove the headache of all of that, it might look something like SeerAI. I was also thinking if I was just talking to another fellow data scientist at a pub or something, we'd talk about what the platform does. I would just say something like, this any data scientist that's tried to work with geospatial data before, you just say we just remove all the headache stuff about the data piece that you really don't want to do. No ETLs, no download, that sort of stuff.
Okay. All right. So I'm going to shamelessly request clarifications or definitions of terms as we go through. We've hit a couple already. You said the word temporal. It'd be good to hear what that means. You also use the term ETL.
Yep, absolutely. Let's start with ETL. ETL is a generalized term for extract, transform, load data. Hopefully I got that exactly right. But the basic idea is you got to move data from A to B. Database A to database B, local data, move it up to the cloud, whatever. And sometimes you have to restructure that data, or reformat it to gel with what you want to do with it at the end of the day. That's the ETL piece. And then the temporal piece. So if geospatial data, which sounds like a big word, is just data taking place in space, the temporal data is the other side of that. It's data taking place in time. We are of the opinion that all data are spatial and temporal data. It's just that sometimes when you look at it, you're looking at a cross section, and so you don't realize it. But it's taking place at some point in the world and at some time, within some larger time span. So kind of think that comprises all data. And that really maybe begs the question of why you would want to redo data management from the aspect of geospatial or spatial temporal in our case. And it's because we think that's the most difficult data to work with. And it's also a lot of the time the extra data that you need to get to the answer that you want. So it wouldn't be remaking the whole thing and saying we're only going to do spatial temporal data. It's saying what does a data management platform look like when you incorporate that as a first-class citizen from the beginning?
Yep. Okay, so I think that's a nice segue to the niche that you dominate. Could you expand on that?
I will. We don't necessarily dominate a particular niche in the terms of a vertical, let's say. So we don't necessarily serve one particular industry. I think if we dominate anything, it's the idea of sort of doing almost anything you want to with basically almost any type of data that you have, and then go out from there. And the reason why we don't have a particular industry that we focus on is because we kind of focus on data, and data are everywhere. That being said, we've had a lot of success with some particular industries, probably more data mature ones. So we've had a lot of successful engagements with the energy industry. And I think
you're in Houston, right?
I am in Houston.
So in Houston, that's expected.
Yeah, but the joke is when you're born, you just get assigned an energy company to work for, and then you just got to work for that one. I'm the only one of us in Houston. Some of my examples may refer back to energy because that's my background. But we've had some success there because I think of our ability to scale solutions really well. And to the joy of a lot of people at the company, we've had a lot of success with sort of like emergency management, disaster relief, which has been really, really buoying to see. And I think one of the reasons why we've had success there is our ability to sort of turn things out very quickly by virtue of the platform.
Okay, all right, good to hear. So then what is the skin in the game of the owners slash management staff?
Yeah, so we're a small company. Everybody's got, everybody has a seat at the table. Everybody's got some vested interest in how the company performs. We have talked about this on and off often. It just sort of comes up in conversation how the real skin of the game, I think, for everybody, because a lot of us come from an analyst data science background, is that we don't want to go back to a world where we can't use Geodesic, which is the name of our platform. It has taken away a lot of the headaches that we've all dealt with as sort of professional scientists, analysts, and it's kind of spoiled us a bit. And we don't want to go back to the world where we don't have that.
Okay, all right. So it sounds like you're all afraid to leave the company where you won't have the use
Well,
the tool.
we've done the counterfactual. Like,
It sounds like you feel sorry for the rest of us.
a little bit. That's why we're here. We want to help everybody, man.
Okay, often a response to this question is there some equity ownership by the staff? Part of the salary that people receive is in fact via dividends from the company, and that incentivizes you to perform well. So the company performs well. Is there that kind of structure in your remuneration?
Yes, there is.
Okay, all right.
There is,
And
which
that's
is
typical for startups, right?
typical for startups. The idea is that you're trying to attract talented people, um, and to do that, talented, really inexperienced people too. So you've got to coax them away from what they're doing, and come work on a passion project a little bit. So the skin of the game is yeah, that financial remuneration piece you're talking about. You said it more eloquently than I did, and also
It's
the
because I
idea
asked the
of
same question everyone.
yeah, yeah, exactly. And I realize I don't answer that question that often, but yeah, it's a good question and an important one. And yeah, at the end of the day, we all have a financial stake in the company's success, to be sure.
Yeah. Okay. Another reason why I asked the question is I come from the land of vast global engineering consultancies. It's kind of the opposite, and there's that uh, way of having a career. I perceive might be new to a lot of people, so I'm trying to sort of uh, open people's eyes a bit to a different way of working. So.
Yeah, no, totally get it. I came from that world before as well, and so there's definitely a big difference.
Yeah.
Yeah.
Okay, so then who's your ideal customer and how do you ensure you're always working backwards from their needs?
Yep. Really good question. Um, we haven't encountered our ideal customer yet. I'm curious if our ideal customer actually exists, because really at the end of the day, our ideal customer is just a bunch of people exactly like us who have experienced, data woes in large organizations, particularly around spatial temporal data, have the wherewithal to understand the problems and to, deal with uh, deal with that sort of data at a technical, like a deep technical level. And so to say, okay, I know exactly what the hurdles are to what I want to do, and I know exactly what I want to do. Let's insert your platform, SeerAI, and I'm good to go. Just give me the documentation and I can roll. I mean, that is an ideal world. Um, again, I'm not sure if that exists totally. And so what we have instead are we really have categories of customers, and we can help all of them, and we really, really try to. And the best kind of analogy that I have, sort of thinking about this, is that um, I like to cook. It's one of my hobbies. I have brothers-in-law that also like to cook. They are vastly superior to me. So, so if you're trying to educate somebody or help somebody with cooking, you've sort of got these three rough categories that you can fall into. You could give somebody the what is it, the Joy of French Cooking, which is a huge tome on difficult recipes, and say, here you go, and then they're like, awesome, I got this. Or you can do the Hello Fresh style, where you send them the ingredients, give them some instructions, have them go to town, but you're kind of there in spirit guiding them, or you've got the personal chef that shows up because you like eating and you want the result, but you don't want to put it together. We've got customers that kind of span that entire breadth, and
This is a
some
great
of the
analogy.
oh,
It's really
thanks.
helpful.
It actually helped me come
I'm
up
going to
with it
use that.
too. Yeah.
Right.
but but they're all valid customers. It's not like one is smarter than. I mean, this is really important. It's not like one's smarter than the other. It's not like one has more technical knowledge or ability or capability than another. A lot of it has to do with where they fall on the data maturity curve. And that doesn't mean their ability to use data. It more means they've used the platforms that they need enough such that they realize where their frustrations are, the things that they can't do with the platforms they have, and they know kind of what they want to do. And so, if they know that piece, it's really, really easy to work with them, especially if they have experience in spatial temporal data. If it is a a customer who is really just working and sort of like just wanting to bite around the corners of spatial temporal data. They're used to a lot of tabular data, maybe even a lot of Excel. It's a different scenario, and it's not like they're not doing incredible things in Excel and basically writing their own software, making models and stuff like that. But you're gonna have to introduce some more context of what geospatial data can do, how you have to manage it, what the limitations are. It's a different kind of lift. Both of them are still, or all three of those are edifying experiences for
Hmm.
sure.
I really loved your point that just regardless of which category a customer falls into, there is no judgment about how smart or adept they might be. They're all valid customers.
Yep.
I
Yep.
liked the
Exactly.
flagging attitude there.
Yeah. At, at the end of the day, they are trying to do a job. They have some sort of task that they need to complete, some sort of answer that they need to get that's germane to their particular industry or their particular company. That's what you're helping them do. That's it. You're not there to wow them necessarily, even though I think sometimes our stuff does. You're there to help them, not to show off, right?
Yeah. Okay. Would it be possible to provide a couple of examples of spatiotemporal problems or spatiotemporal data that customers have come to you about? I think it would be good to, give some examples of what this data can be about.
Yeah, absolutely. I'm going to try to do it maintaining that analogy.
Yep.
Um, I might fail, but let's see how it goes. Um, the first one, let's start with sort of a more complex one because I think that's interesting, and I think it'll do good to define sort of like the breadth of what we're talking about. Maybe bookend it a little bit. We've had one really, really great public engagement with ExxonMobil. So we were fortunate enough to work with their Papua New Guinea group. They presented the findings at Esri UC, which is the user conference in San Diego every year. It was a really, really great engagement. The crux of it was that there is a natural gas pipeline in Papua New Guinea that's an incredibly seismically active area, more than I ever knew. Earthquakes all over the place, but there's a natural gas pipeline there, right? We see the issue. Those two things don't mix well together. And what that group is charged with, partially, aside from the many other tasks that they have to do during the day, is to monitor the integrity of that pipeline. That's difficult to do along a 700-kilometer pipeline. And they've got a lot of other stuff to do, by the way. The way they would typically do it in the past is look for seismic events, which are reported and recorded. If there was a seismic event close to the pipeline that was deemed, substantially high on the scale, they would go out and then manually inspect the pipeline, either walk it or charter an aircraft and go look at the pipeline. A lot of it's buried though, by the way, so that only gets you so far. And the ask was, is there a way we can utilize satellite data to understand what's happening at the surface around the entire pipeline? because that will give us not only the ability to understand quickly what the potential impact is from seismicity, but it will also give us a way to understand sort of like cumulative effects over time, right? Because it might not just be one big event. It could be a lot of little events that affect it.
Are you saying
So
that over time seismic events can cumulatively shift the pipeline in a certain direction?
Indirectly, yeah.
Wow.
Because so this area, not only is it incredibly dense jungle, it's also incredibly varied terrain topographically. And you have to think about what's going on below the surface too. There's different soil types, different soil moisture types, different lithology, so different rock types, and all of those things, result in this incredibly dynamic system. They're really, really cool, by the way. But trying to model what might happen with a pipeline from a seismic event is a difficult process, right? So what we did was take satellite data. It's a particular type of satellite data. So this is from synthetic aperture radar data, which is sort of the darling of satellite data if you want to see through clouds and get high resolution information. It does some incredible things. And you can generate products from that. So we generated 2 products from that. One is amplitude change detection, and one is interferometric synthetic aperture radar. It's called INSAR.
I'm waving
yep,
the definition flag.
Let's pause. Let's pause. Really, really, complicated mouthful of words. Pretty simple concept. So our satellite flies over point A, right? Snaps a picture. Sometime later, it flies over point A again, snaps a picture over the same location, but maybe a little bit before or a little bit after. And so you get this nice cone and you generate an image. One of those images, so products that you can generate from that image, amplitude change detection, shows you where the amplitude of that signal, so the strength of the signal, has changed from pass 1 to pass 2 or pass 2 to pass 3, and it gives you a really good conception of where big changes have occurred on the ground. Landslides, construction, heavy equipment being moved, something like that. INSAR does the opposite end of the scale. Same idea, pass 1, pass 2, we're getting a high resolution image and we can see what's changed. INSAR is really good at showing us where there are sort of very small scale changes at the surface of the Earth. And we were looking at both of those things. And the reason, kind of clear when you think about what's going on there, sometimes earthquake could happen, you could have big landslides, trees fall over, mountainous area, parts that, you get land slumps and things like that. Or you're just looking at little changes along the pipeline. But if it's a place where the pipeline is supposed to be incredibly level, you might need to go check that. So we took a lot of historic data sourced from INSAR. We took lithology, which is publicly available data. We took soil moisture types, and we just sort of stacked them all together and made this really, really cool predictive model that was able to, where it is currently able to say, if there's a seismic event at this location, here's the expected ground deformation change across this large area, or here is where we are detecting big changes from amplitude change detection.
So this is like next level constraints assessment. You could build that into a least cost path assessment in a feasibility study.
Yeah, that's actually perfect. There's that we can either stay on this for a couple more minutes or segue into a really good example of that. But that's the kind of data that's like that's a pretty complicated problem, and it's also not that easy to understand as well. So we had a lot of discussion back and forth with the Papua New Guinea team. Again, you would assume, and you'd assume correctly, that this is a hyper technical team. I mean, they engineer and manage a 700-kilometer long natural gas pipeline. This is not easy stuff to do. But if you've never encountered amplitude change detection, if you've never encountered INSAR, if you've never used satellite data, if you're really not used to machine learning models in this sense, we can call it AI, but if you're not used to looking at predictive modeling like that, you're gonna have some questions. One of the really interesting ones that we sort of often got stuck on is that the earthquake, the ground deformation resultant from seismic event was a prediction. It's really hard to measure in that area. So we had to make a model based on past information where we actually had observations of surface deformation. We didn't have that in a ton of places, so we had to sort of like take where we had it and interpolate and make a predictive surface across the whole area. For ACD, it's a lot more forgiving. We were able to measure that. And so, you know, we've got this great dashboard for them that we don't ETL any data, right? Call back to our earlier definition. We don't ETL any data or download it.
Hang on, and you said ACD there, which is amplitude change detection.
You got
right?
it. See,
Okay.
now you're
All right.
now you're an expert. But for them, it was this. We kind of had to consistently revisit this idea of like one is making a prediction and it's a model, and one is making an observation.
Yeah.
And if you're not used to that, you kind of have to think about it often. See, we run into stuff like that all the time. It's again,
okay.
Brilliant set of clients, right?
All right. Okay, so from that example, I'm convinced that SeerAI can be the kind of cook or chef that uses a French cookbook
Yes.
and produces some incredible bespoke large-scale systems of prediction for some of the world's most high-profile clients. Have you got an example at the other end, perhaps, where it's a much simpler example of dealing with spatiotemporal data?
Yep. Fantastic question. This example, compared to what we just talked about, is going to seem so pedestrian. It's such an important example, though, because both sides of the spectrum matter almost equally as much. One of the things that but before you start any project with our platform, you connect out to the data that you want. And so the way you can do that is essentially we've written a bunch of APIs on steroids that connect to really anywhere you want. Snowflake, AWS, Azure, ArcGIS, whatever, any sort of database that you want to connect to, really any type of data. So that's sort of like step one. So you're just making that connection. You've got this virtual representation of the data now in front of you. When you do that, you're able to then make dynamic actions on that data. If it's tabular data, you could add fields dynamically. You can do lots of other things. We've got utilities built in for that. A pretty common thing that you want to do with geospatial data is join dataset A to dataset B. A more poetic way to say it is enrich dataset A with dataset
I've heard
B.
of this term.
Yeah. So what are we talking about? That is very simply the idea of that dataset A has a little bit of what I want, dataset B has a little bit of what I want. I want to make a new dataset that has both of those things. So sometimes dataset A is not spatial. It's just tabular data. Maybe it has a key value field in it or something like that. And dataset B is spatial, but it doesn't have the information that dataset A has. So you want to join them together and you want to have a new data set. Traditionally, what that looks like is you download dataset A, download dataset B, join them in a software, a platform. The result is a completely new data set. Right? It's cleaved from the first data set. So we've broken the chain of provenance. Already kind of an issue. And then we get that data, that new data set, and we're kind of stuck with it. Wherever we made it, we're kind of stuck with it. That may not seem like a big deal, but if you're at a large organization, institution, a government department, that can be a big pain because what do you need to do with that data? All right, so here's the example, case in point, right? When we've done this a couple times with like local governments, county level, city level, think about emergency response data. If a fire department or police department gets a call, they need to go to some building, right? The location of that building matters. The type of building really matters, right? And what we never think about is how they got that data in the first place. Chances are there's not just some data analyst at the fire department looking through all of the building permits and new building construction and verifying locations. Like, that's not happening. The fire department data is connected to somewhere else. That data is connected to somewhere else, and there's a chain, and that's how that data ends up there. So we've had several engagements where we say, look, okay, there's let's say a permit department, right? Permit department in the city or local government, and they are in charge of new permits, which denote the building type. And there is another department that maybe is responsible for managing the location of those building parcels, right? So those are the two sources of truth. And the fire department data has to have both the location and the building type. Well, what happens when like the building permit type changes or something like that? Or what happens when one building gets knocked down and that is recorded in the building department, in the building permit database as, let's say, it moved from like a government building or something like commercial building, and now it's a school. And what if you've got this old joined data set that's just sitting there, and now all of a sudden your fire department is responding to a commercial building instead of a school? That's a problem.
Anticipating the wrong kind of materials, arriving with the wrong kind of firefighting equipment, didn't bring a ladder. Okay, gotcha.
Didn't bring enough equipment, right? There's a mandated number of vehicles that should respond to a school. This is an issue. And weirdly, that it all dovetails at this static join data set. I mean, that's something you would never think about. But because we can make these connections dynamically, and because we can do them to any database, you could have Department A in that local government using some database, Department B using a different one. We can connect out to those, make a dynamic join, and if something in database A or dataset B changes, it's reflected automatically in real time in that join. And so now it's like this really, really big problem that you had that dovetailed at a data issue. You can just resolve it. It sounds really pedestrian, but look at the example we came up with. I mean, it's super serious, right?
Okay, and the temporal aspect there is that over perhaps the years or at least the decades, you can see those shifts in the usage of a particular building or a plot of land.
Yeah, absolutely. Yeah. Absolutely.
Okay, yep. And if you animate a map with that data set, you could see the categories of use changing over time. So the map suddenly we're moving then from a static map, which you've got on a piece of paper, to a little video, a movie that you can play on the screen with this kind of data, which I really love, and I feel is it's a huge, the public and regular folk, I feel, can far more easily connect. The data comes alive. There's a more visceral feeling that you can get from spatial temporal data than a simple static map. So I'm excited by it, and it's been a highlight in my career. Yeah, and also there's only been a few examples in my career really where I've done spatio-temporal stuff. The first major one was urban poor communities. A data set over, I think it was 2 decades worth of eviction events of urban poor communities in Phnom Penh, the capital of Cambodia. It was an NGO that I was volunteering for with Engineers Without Borders Australia. And basically the whole point of my placement with that NGO was to build up this database, which could be used to create a spatio-temporal animation of eviction events and relocation events from slums, or the politically correct term is urban poor communities in the center of Phnom Penh, to relocation sites on the periphery of the city. So yeah, it's much easier to understand these kinds of issues when you put in a spatio-temporal animation in front of someone.
That's a really cool problem. Were you able to see interesting patterns emerge from that?
Yeah, and also we could use it to check the quality of the database. So sometimes there was a eviction event date that occurred after the relocation event date. So you saw them shifting to the relocation site before the database said the eviction occurred. So yeah, So it was also useful for something you wouldn't think of, but you can use it to check quality in your database and animation.
Yes.
Like who would have thought that you could use an animation to check quality, but you can. The human eye is more easily able to see it.
Yeah, that's perfect. Yeah, that's fantastic.
Yeah.
And I mean, so just the idea of I hadn't thought about looking at permit changes over time or like building type changes over time. So like, is there an area where you're seeing more building type turnover in a particular area? I've never thought to look at that. So that's the beauty of this, is that, you know, we want people to sort of like chain these ideas together themselves and say, oh, you
Yeah.
know what would be really, really neat? And then it's sort of like, our job's done. Now you're off to the races.
Yeah, but this is fascinating because you're bringing up clustering, and clustering is such a common thing to do in spatial analysis. Like, where is the high density of uh, points where change happens? So, but then this also brings up where is the clustering in time? Whereas, you know, the stretch of 5 years where all the change happens, and then
Yes.
over the stretches of 5 years before and after, there's no change. So yeah, it's exciting.
Yeah, I mean, that's kind of a perfect segue. I was thinking one more example was
Yeah.
that um, there is, for a decade now, I guess, there's been tons of satellite data available, so many different products that you can get. A lot of times the question is, what can I do with it? You know, it can be really difficult to use. Um, and there is a really appealing first pass quality to looking at an image, a static satellite image, let's say, um, visual or otherwise. But oftentimes what you want to do is like what you're describing. You want to look at it over time. You want to see how one space compares to another. That's difficult to do. And I think a lot of times when people have an aha moment with us is that when they're able to, having never worked with satellite data before, and we don't just work with satellite data, but that tends to be interesting data that a lot of people want to get at. When they've never worked with it before, when they're able to connect out to it, look at any particular spot on the globe that they want to, get that data over time just as pixels, so the raw data, turn it into a time series, and now all of a sudden you've got this temporal curve of a thing you're looking at that now you get to compare with anything else that you've made. Right now, all of a sudden, this really, really heavy lift is just another time series that you have at your disposal, and it's super powerful, and it's somehow bizarrely satisfying to see really, really complicated satellite data be compressed into just a line, just a time series, and you're like,
Right.
oh, that's all it is. It's just values over time, and then, you know, that sort of opens up people's aperture a bit.
Well, yeah. Forgive me. I have to ask a philosophical question. Can we know reality without time?
Um, that is a deep philosophical question. Everything is everything occurs across some continuum, that temporal continuum. I don't know. I think it's sort of a turtles all the way down question, because when you're asking if you know something, you're asking if you know something relative to something else. I mean, when you're trying to coax information out of a set of data, to inform you on something, you're trying to contextualize that information with things you know. If you go up to an abandoned house and you see a ton of broken windows, and you go up there the next day and you see an additional broken window, that hasn't given you a lot of information. If you drive up to your house and you see one broken window, you've contextualized it. That gives you a lot of information all of a sudden. I think it's the same thing can be sort of extrapolated to talk about, can you know anything without time data? Sure, you can know something. Like you can look at an image that's static in time, that's just a cross-sectional piece of time, and you can know where things are located relative to each
I
other.
love that you said that that's a cross-sectional piece of time. That's, I guess, what I'm trying to like. Maybe I should provide some context. I just hit you with this question. It's not even in the
It's a
agenda.
great. I'm going to think about that one later for sure.
So if I can provide the context, I used to work at by some accounts, the world's best international engineering design firm. We had a really great bunch of what in other consultancies and in earlier times in my career, pardon the pun, were known as a surveying team. They called themselves the reality capture and surveying team. So I'm seeing in our surveying brethren that they are reclassifying themselves to as reality capture people, I would just say. And I think what's prompting them to do that is, they would walk, they had these LiDAR capture backpacks, and they could just walk around a site or a building, and it would, capture reality, basically. Occasionally they come along with the Boston Dynamics yellow robot dog that also had a laser sensor which would do a LiDAR survey. So I feel that for others in the geospatial field, we need to be paying attention to those who are capturing the data that we work with, saying that they are capturing reality. To keep up with them, perhaps we need to think about how we are reality modelers, we are reality predictors, and what you seem to be contributing, and SeerAI seems to be contributing to this, is that time and the series of events spatially over time matters.
I think you said that fantastically. I also think reality capture is just a fantastic marketing name. I mean,
It sounds so badass.
Whoever came up with that is brilliant. It's two sides of the same coin. In geography, you've got this idea of the modifiable unit area problem.
Yep.
Right? If you're trying to, I won't assume any knowledge. So if you're trying to understand, the density of buildings within some area, that number can change as you expand or contract the area. It's arbitrary, but it's important, right? You have the same idea in time. It's just that instead of looking down at a polygon that's contracting,
the modifiable time unit problem.
Yeah, 100%. Because you're looking at time windows and you're looking at time intervals, and you're having the same expansion contraction closures that you're having to make. And the point is that they just give you different versions of reality. And so to get a more complete picture, you kind of need to iterate. Now, where it gets really interesting is that you need to do that temporally and spatially a lot. And sometimes you need to do it with really difficult data. And then that circles back to, what does your world look like if you're actually trying to do that and you've got sort of a legacy set of tools? It is difficult.
Got you. That haven't been developed with spatiotemporal analysis in mind. And that's then the gap in the market, if you like, that SeerAI is filling. Okay.
Yep. And I think there's a move that we're trying to make within the idea of geospatial data platform services or spatial temporal, and like the rest of the broader organization, whatever organization that this stuff happens to be in. And geospatial itself has kind of an interesting, complicated history. I think you could trace it back a lot to the complicated history of geography in the US, but geospatial, because we all know that it's so relevant and important, has spent a lot of time sort of yelling about that. And one solution to being included in the discussion is to carve out a niche, to carve out a corner of the organization and say, this is the geospatial organization. Our data are different, they're important. As we're discussing right now, they play a great deal into understanding the reality of the situation, and so we need to exist. The flip side of that is that you've carved out your own little corner. It's a lot more difficult to get a seat at the larger organizational table that needs geospatial, kind of understands geospatial, but is also happy to have it floating over here. And that made a lot of sense, I think, for getting geospatial the clout and recognition it deserves. What we need to do now, I think what the move we're trying to make is to say, you can't have it both ways now. We need to integrate with the rest of data because frankly, we're needed. I mean, to really scale AI solutions, to really get the answers that you want, you need spatial temporal data. It's not going to work if you just have it sitting in the corner. Your solution's not going to scale. You're not going to get the input data that you need. It's just not going to work. So like we've got to make this move that says spatial temporal data is really, really difficult to work with and to deal with, but it's also part and parcel of a larger data picture. We can't segregate ourselves anymore and sort of expect more movement on the geospatial front.
In a way, it sounds like the move you're trying to make is you want to make it as easy to work with as the data people usually chuck in Excel and put a couple of formulas against, and then they've got their little table.
That's exactly right.
Okay.
That's exactly right. You need to think about incorporating geospatial data, read spatial temporal data as easily as any other type of data.
Yeah. Okay.
And you need to know that you need to do that.
Yeah. Cool. Okay. So then that's a great segue to how fast and sticky is growth.
Not as fast as we want. I don't know if it'll ever be as fast as we want.
Everybody says that. And I always respond, everybody says that.
That makes me feel better. That makes me feel a lot better. Not as fast as we want probably for a couple of reasons. One is it's, you had Linda Stevens on a while ago. She just had some fantastic points. One of her best ones was marketing is essentially education. There's an education piece we have to do. That's a big reason. And you're working with large organizations a lot of the time that tend to have very long sales cycles. Those are sort of good, practical, on the ground reasons. But I think a more interesting reason is that we are in this interesting inflection point with AI and lots of new sort of like software platforms coming online at the same time that legacy systems are existing. A lot of new platforms that promise the world, a lot of legacy systems that have carved out like these big, deep trenches. And so one of the things that we kind of need to happen is for people to understand the problems that they want to solve, understand like that they can't get there necessarily all the time with some legacy systems they're using, have their frustration build enough to where they can appreciate, oh, okay, Geodesic can come along and really like solve a lot of these problems. So there's this sort of dynamic that's occurring that's not just, hey, look at how cool this is and how we can make your lives easier. And people say, fantastic, take my money. Right? That would be an ideal world. However, the positive flip side of that is that we tend to be very sticky. The data scientists in-house are the best example for that, but we've had enough examples where we get used and people really realize, oh, okay, I can't go back because I wouldn't know what to do, especially if that's your first touch with spatial temporal. Actually, especially if you've worked on a lot of legacy systems too. You're like, okay, this is really nice. I have eliminated a lot of my headaches. I've sped up a lot of my work. I'm doing things I couldn't do before. That's the really good flip side of maybe not being as fast as we want, is I think we're pretty sticky.
Great. Okay. So let's shift gear a little bit. I'm going to give you a hypothetical customer. His name's Johnny Harris. He is relatively well known on YouTube. I think he's accumulated about 5 million followers.
Yeah.
And his latest video was about going to the northwest Saudi desert, a province called Tabuk. He hung out with a few Bedouins. They're people with sort of many thousands of years worth of connection to the land. Up there. They wear very distinctive dress, as I described in the last episode with Jordan Regine, a white long gown called a shamar. There might be other names, but that's the one that I'm aware of from the time I spent, especially in Kuwait. And there's also a traditional headdress. All of this is to cope with the incredibly hot weather there. And I should say that I really love wearing a shemagh. I love the pockets, especially as I also said with Jordan. So kudos to Johnny for arranging this encounter with this ancient tribal community and spending time eating, sleeping with them in these amazing places under the stars and in these incredible, speaking of lithography, rock formations in the desert up there. Anyway, so what Johnny came across was the world's largest construction project, a linear city called The Line. Literally a line that was going to be 170 kilometers long has now been scaled back to 99% smaller, around about 2.5 kilometers long. So if I gave him to you as a customer trying to make an impressive video or improve his videos to look at this development, this construction project from a spatio-temporal perspective, what would you do?
I mean, this is sort of bearing the lead, isn't it, Will? Because this is, I mean, this is how we first became connected, right? This idea. So maybe we just sort of like take the like reveal the whole thing. Is it, essentially why you and I started talking is because something we do as a company is try to post free content on LinkedIn, just stuff that we think is interesting. Obviously using our software because at the end of the day, we want people to utilize us. But we put stuff out there that we think is cool to look at. And here, have a look. And one of those things was this idea of looking at construction progression for the line. And this, we put a good amount of thought into a lot of what we put out. Sometimes we need to put things out quickly and things just spark our interest, right? So it's not that we are not a incredibly thoughtful company, which we are, and sometimes we need to get stuff out quickly. And this was one of those instances. And I actually think it does a lot to sort of like speak to how fast we can get things out, right? So we had a post we had originally planned. It wasn't coming together just narratively. We kind of took a step back and said, I don't know what people are going to think about this. It's just maybe too many words, right? Too many details. And so I had just seen that Johnny Harris video. This was at 3 o'clock on a Tuesday, and I said, let's look at the construction progression on the line. Let's see if we see anything. Okay. Sure enough, we saw this really interesting progression of where construction was taking place across time and across the line. Put it out as a video, a map animation on LinkedIn. From time to thinking about it to putting it out, what's really neat is that it took about half an hour.
Crazy.
Yep, really, really fast. And again, didn't download any data or anything to do it.
But hang on, I have all sorts of questions now. I'll let you, because you've already introduced us to the fact that it was using geodesic, right?
This was using geodesic, our platform.
So you said one of the things you said is that you don't need to get any copies of data. You don't have to wait for days to download something. You make a connection to an external data source. So could you start there?
Absolutely. So this is a callback to ACD from the beginning of the conversation. We were using
amplitude change detection.
I knew you had it. I knew you had it.
Doing my best here.
Exactly right. Amplitude change detection. So we can get a little bit more into that. Amplitude change detection is again a post-process satellite product that you're getting from synthetic aperture radar satellite data, a great source of which is the Sentinel mission launched by the European Space Agency. So here we've got the ESA, we've got the Sentinel mission, we've got synthetic aperture radar data collected from that mission, and we've got a processed product from that, amplitude change detection. So, step 1, step 2, step 3, step 4. You can get Sentinel data from a couple different sources. It's publicly available. You can get it directly from ESA, Google Earth Engine. I think ArcGIS Living Atlas has a cross-sectional version, like a truncated version of it. And this is something we'd done before. That's partially why it was easy, because we knew what we were looking for. But step one was making that connection out to the Sentinel data in Google Earth Engine. Spoiler alert, we'd already made that connection. So once you make the connection, it just exists as a data set in the platform. So all you're doing is hitting that data set over and over and over again. You don't have to keep making the connection. So that was already sitting there, right? Because we'd already looked at this stuff. The second part of it is actually having a set of instructions and algorithm to generate ACD, amplitude change detection, from that data set that you've connected to. We hadn't touched on this yet, but one thing that we're able to do is take off-the-shelf models, algorithms, machine learning models, AI models, and run them at scale on data that you need. So right now we do that through doing what's called containerizing the model, putting it up on the web, and feeding it as it's called a Docker image to our platform. We have plans to improve that workflow for people that aren't used to doing that. But essentially, we had a great data scientist on our team, Chloe, who had done this work before, who already had an algorithm written for ACD. And once you've got the data connection and once you've got the algorithm, super easy to combine the two. And it really is just a matter of, where do you want to look? Oh, okay, here's a bounding box for the line. Let's look there, generate ACD. We shared it out as web tokens, or as one web token to a ArcGIS Online web map. It could have gone anywhere. We just happened to be using that. Hit record, put it up as a video. What does it tell us, though? That's the important
thing. So you're telling me it's in addition to a video, it's an actual browsable web map that you can users can look at?
Yeah.
Is including the public? Will we be able to have that link in the show notes?
Yeah, I think we can make it public. I don't see why not.
That will be sick.
Yeah.
So are you telling me the bounding box was the entirety of the 170 kilometers of the line?
I think I forgot where I drew it. If the line stretches from sort of
from the coast in
the tip of the Sinai, basically, to yeah, it was about that big. Again, it was mostly, it wasn't arbitrary. I was trying to capture the line, but okay. I'm telling you, this was quick. I just looked at sort of where the bounding box was and just was like, I think it's there.
Okay, but the point is, we're looking at tens of kilometers here. It's not just the 2.5 kilometers that Bloomberg reported the scope has been reduced to. That's an important point to say. Okay, and then the result was, hang on, so a couple more questions. What is the resolution of the SAR imagery, or European Space Agency synthetic aperture radar imagery?
I believe at that, it varies location to location, but I believe the average is about 10 meters resolution.
Okay, so what we're saying, what does resolution mean for the layperson?
Think about looking at the Earth and imposing a large grid of squares on it, and each one of those squares has an area associated with it. For any particular instrument, that area is the resolution, which you're able to actually sort of like make out with your eye on the ground. So as those boxes become smaller and smaller, that is the extent of your resolution. So 10-meter resolution is, fly up in a plane, think about a 10-meter by 10-meter box on the ground. You can that's sort of like what you can resolve. Anything smaller becomes blurry.
Right. You can't detect change at a smaller scale than the cell size.
Much better said than I just did.
Put it. Yeah. Okay. Cool.
Yeah.
So you're talking about, in this analysis, something like 10-meter resolution for you can detect change on the Earth in response to these construction activities at a resolution of 10 meters, but not smaller than that.
You got it.
Okay, awesome. So yeah, what was the result? What did you see?
So we saw what we wanted to see, which is really good. One caveat, and this is something that is, a continuing sort of thorn in the side of working with satellite data, is that if you're looking at images over time from satellite, like not every single image is perfect. There's lots of reasons for interference or mispass or whatever. Like there are issues with having perfect satellite data all the time. In this case, we got really lucky, and we were able to see a really nice progression over, I think, gosh, now I can't remember the dates, but I think it was maybe a 4-year period. Maybe
I
a little
remember the
bit.
first one was 2023, the whole of 2023, but then I asked
2023,
you,
yeah, that's right.
I asked you to
Yes.
do it back to 2020 because I know that there was some clearing of villages for those Bedouins or others to
Yes.
make way for
Okay.
the line.
That's right. So the first pass was, let's say, about 2 years worth of data. And the idea with ACD is that you're going to see which pixels change. If you say that, and you kind of, what we do is we set some sort of arbitrary threshold on the number of pixels that were changed. And if there's a certain number of pixels that change, you sort of have a bounding box or a polygon drawn around them, so that what you see then on the map are these polygons, these shapes of change that have occurred at a level to sort of like tip the threshold, right? So you can say, okay, I'm pretty confident that this area changed from time A to time B. You sometimes need to be an expert in what you're looking at to understand what that change actually means. If we're looking at Papua New Guinea and we have on the ground experts telling us, hey, there was a landslide here, can we see what that looks like? The change that you see, the change that you detect from ACD is probably going to be a landslide, right? In this case, we don't really have to be experts in what we're looking at because you can see it from Google Earth images. You're looking at this just massive construction site.
It's basically a long trench.
It's one of the most bizarre things I've ever seen. And it's nuts. And I'd never really looked at it before, and so just to see it, like, oh my gosh, this is huge. So what we see is this progression over time of where construction is taking place. So think of this giant, linear trench that you're talking about, and you've got places lighting up over here in this corner and here and this corner and here and across the middle, and you see it kind of change over time. Generalizing that, you can then tell a lot of stuff. You can see generally like how the construction has progressed over time. You could think of let's say for each month or each 6-month period or something like that, counting the number of detections and getting a temporal curve from that. You could look at spatial-based clustering. You could see where there is more or less activity. You could sort of look at seasonal changes if we were to extract that data out longer over a couple of years, and then you could make predictive expectations on what sort of activity you might see going into the summer versus the winter, right? It's all just stuff that you can play with. And that's just from one sort of product, ACD. And what's really interesting is if you start to pair ACD, start to integrate that data with other data, which is how we would really, if we had more time, that's really how we'd want to look at this project. If you're Johnny Harris, we'd say ACD is fantastic. It can really tell you a lot about where big changes are taking place on the ground, but you can also look at where vegetation has changed. You could look at drought conditions, and you could see if precipitation influences what progress is taking place. You could look at other satellite products like VEERS that's able to detect lights on the earth, on the surface of the Earth. So you could look at VEERS nighttime lights and see where people VEERS, VIIRS. I'm not going to remember the acronym. I apologize. I'll have to send it to you. But it's another satellite product, and the idea is that one of the things it's used for pretty often is to look at nighttime lights on the Earth, or heat signatures sometimes as well, and see, you can think about flying over a city at night and seeing the cluster of lights denote how the city's arranged. Exact same idea. Right?
Okay, so you circled back to Johnny Harris there. I just wanted to, I guess, close out what I was setting up. To me, his video was impressive, right? There were incredible panoramic shots of the amazing landscape, and also just him driving down a road and looking at all the trucks that were using being used to transport all of this material. But what was missing that SeerAI and your geodesic product and this ACD spatial analysis can bring is the money shot, basically. Accompanying him narrating that it was so mind-blowing in scale, what was missing, the money shot, was this animation based on an ACD analysis of the whole evidence of construction over time from start to end of the site. So I really feel that whilst Johnny Harris does a lot to promote cartography, particularly, and at the Adobe Studio end, you know, the artistic and graphic art end of what we can do. What's missing from what Johnny Harris does, as sort of in the mind of the public, one of the foremost sort of messengers about mapping and geospatial, what's missing is the power of spatiotemporal, in this case, analysis. So what I'd love to see from this discussion and from our industry more broadly is thrusting into outputs from the likes of Johnny Harris, but maybe also spinning up an incredibly inspiring content creator that leads with these kind of spatiotemporal and other analyses that the likes of yourself at SeerAI can do.
Yeah, I think that's perfect. I think it really underscores our different approaches to it, like what we would think of to look at and what someone like Johnny Harris would think of to look at, underscores where that gap is. Because I looked at that video, and I'm not by any means like special inside of our organization or the geospatial community. I looked at that video and I thought, when he was driving by all those trucks and seeing all the spotlights of construction at night, I thought, oh, I bet you can see that using satellite data.
Yeah, so maybe it's just awareness on his part. And again, this is not to criticize Johnny Harris. Again, he does a service to our community. He keeps in the public's mind, and he does a lot of dramatic videos hamming up the cartography process. And he's tried himself to actually help people to do the kind of video production around cartography that he does, especially in, as I said, the Adobe Illustrator type suite. But there's a lot missing. And it's on us in the geospatial community, the spatiotemporal community. Actually, it's on us to fill that gap and to really help the public understand the level of understanding that we really can get, because the graphic art approach to cartography is bonkers. It's amazing the kind of infographics that those professionals can create. But equally, there is more understanding that's possible.
Yeah, I really well said. One of our premises is there's a lot of information locked up inside of data that are difficult to access, and also just knowledge that doesn't always exist, that you can go and interrogate these types of data sets and get information.
Hang on. That's a perfect segue into explaining what SeerAI's geodesic is and some stories of how customers have used it.
Yeah, sure. So geodesic is the name of the platform, right? SeerAI is the name of the company. Geodesic's the name of the platform. We get questions a lot on the AI piece as well, and we don't have sort of a magic AI that gives you all the answers that you want. It's a pretty difficult lift. I think we think of ourselves as more of sort of like one of the biggest winners thus far in the AI space is NVIDIA. NVIDIA doesn't make artificial intelligence; they make chips that help you make artificial intelligence models. I think we think of ourselves more along those lines. So the pick and shovel purveyors to the gold rushers. We view ourselves as a tool to help you form and scale your AI or other analytic needs to solve real problems. So that's the AI piece, and in our experience, that's the hard piece. The hard piece is not pressing go on a model; it's doing all the heavy lifting before and after you do that. And so geodesic is, I don't know how deep we want to go, but it's essentially made up of three components that serve three ideas that you need to stitch together in order to, fully realize the solutions that you want to. And the first is connecting out to data. When we're talking about spatial temporal data, again, we're talking about connecting to data that is difficult to, sometimes difficult to access, definitely difficult to work with, and certainly difficult to scale. And so by connecting out to that data instead of moving it, by virtualizing it and then incorporating a set of tools that allow you to do dynamic work on that data, we hopefully eliminate that large heavy lift piece. The second part of the platform is the sort of analysis and data connection piece, and kind of put those two together. But once you connect out to a data source, it's represented inside the platform as a data set. The data set is stored inside of a graph database, which is something, an interesting concept we hadn't really talked about. It's got a lot of deep spatial roots in and of itself. What the graph database allows you to do is to say, have your data set A connect to data set B. So you've got this idea of nodes and edges that form your graph database. And so you're able to query data sets, let's say ACD, for example, and you're able to see which data sets are connected to ACD. You're able to see what data source, like Sentinel, is feeding that ACD model. You're able to see what data sets or projects or whatever are connected to the output of that ACD model. So it's an idea that's a little bit beyond just storing data in tabular format. It's connecting data sets to each other and to different projects so that you can get sort of more data about your data, but also so you don't replicate work. So you're able to reach across disciplines, reach across business units inside of an organization, and realize that you need all this data to get solutions. When we talk about doing artificial intelligence, and I think of it as machine learning still, what you're really talking about doing is folding in a lot of disparate data sets together that sort of cross different business unit boundaries or discipline boundaries because they have some sort of nonlinear interaction that you're trying to understand. It makes sense that your database, the way those data are stored and connected to each other, should do the same thing. If that's what you're trying to do with data, if you're trying to get it from all different places because it's all different types of data and get some solution, you probably should have a different way of storing data than just saying, I'll use an oil and gas example, like well data goes in the well database only, right? And drilling data goes in the drilling database. I mean, we have to be able to reach out across these different databases internally easily. So that's the organization piece.
I wanted to just link this. So I have this habit now on the podcast because I've had 50 plus episodes and I've talked to so many different organizations. So I just wanted to flag that this is not an uncommon concept. So when we had spatial risk systems on, Ken is the CEO in Manhattan. He used to work at FactSet. A theme of his posting on LinkedIn is about knowledge graphs. And of course, he's added spatial to it, so he used the term spatial knowledge graph. So I just wanted to say that it's not uncommon what you're talking about.
Yeah, and that's a good point, and it's good that it's becoming more common. This idea of knowledge graphs, semantically representing how data are connected to one another.
Sorry, I interrupted you. I just wanted to, yeah.
No. Because it's interesting how I think are encountering more and more potential customers who are familiar with knowledge graphs, which surprises me. Perhaps they're more familiar with that sometimes than typical geospatial analysis. That's always.
I should say, sorry to cut you off again. I should just want to say he provided the same reasoning as you. He said that for SRS to have a chance to participate in the generative AI trend, he is making sure that they use a knowledge graph because that is easiest for, or is a way for generative AI models to traverse a set of data or some sort of a knowledge output. So
Yep.
similar messaging I wanted to say.
Yep. Nope. Certainly. And that's that you could do 2 other episodes on that, on the confluence of like knowledge graphs within sort of AI models and also like outside of it and how data is stored. I mean, that's a fascinating space. But so that's like the how data are stored and organized piece. There's a bit in there as well as how you I'll say analyze the data, but really we have a sort of like a lot of dynamic processes that you're able to attach to data via something we call middleware. So when your data are represented from the source, it's now a data set in your graph database. You may need, that data might not be exactly how you want it. You may need to do a spatial join or an attribute join. You may need to add fields. You may need to, if you want to represent the data, which we'll get to downstream in a dashboard or something like that, you may need to adjust the color map on the data. You might want to do inverse distance weighting on the data. We have a suite of utilities built in such that you can do all of that work dynamically on the data that you are connecting out to, so that we can, as closely as possible, stick to the idea of not moving data. So leave the data where they are, do the work you need to do on it in the middle, and then do whatever, send it to wherever you need to, be that a web map, some sort of downstream analysis, whatever. Mm-hmm. So that's the analysis piece. And there's sort of an additional piece tacked onto the analysis piece that sometimes we get into with customers, sometimes we don't. It depends on their needs and their appetite for doing this, but there's just like this idea of a scaling piece. So the might be helpful to name the components now. So the first component, we have a lot of physicists on our team, so these have all physics names to them. So the way we connect out to data is called boson. So it's become somewhat of a verb internally. Boson it. All right.
I just want to say here, finally, I think I've got an episode my wife would want to listen to because she's a physicist.
That's why we're here.
So please go nuts.
That's why we're here. So she'll love a lot of our component names and a lot of our logos as well. She'll be a fan in no time. So when we're utilizing boson, we're connecting out to that data. Boson is also responsible for a lot of the dynamic actions that you do on top of the data. The organization piece is called entanglement. I'm sure she'll understand that aspect of it as well. So that's the knowledge graph. When we request data as a user, as an analyst, you're requesting data from entanglement. You're no longer worried about that connection because that sits there.
I should say, as a naive outsider, though, using the word entanglement in the same sentence as organization doesn't come across as
I hadn't thought about it in terms of organization. We think of entanglement as reaching across space and time and connecting two data sets
the
together.
Tentacles of all the connections. All right.
Yeah, maybe it's a tortured analogy.
I can accept that.
And then the last piece is our analytics engine. That's called Tesseract. You can get through a lot of analysis just using boson to connect out to data, manipulating it in any way that you want, and using entanglement to connect data sets, request data. We can get away with a lot of work doing that, and sometimes you need a heavier lift. If you want to run a off-the-shelf AI model, case model from Hugging Face, Esri's got a ton of models. If you have a proprietary model that you have engineered and want to run that on data that you've connected out to, Tesseract is what that is for. And also, if you want to scale up your analysis, and this is really important. We've got this idea of scale built in. Tesseract runs on a Kubernetes cluster. We're able to horizontally scale any job that you have inside of that. there's a bit of proprietary secret sauce that allows you to do this sort of like large scale analysis on spatial temporal data. That to do that, you've got to break the analysis into little bits and then stitch it back together in a way that makes sense as a map or as a time series or something like that. You can't stitch it back together randomly. And so with Tesseract, we're able to do some really, really amazing stuff. Case in point, we've done this a couple times. When I spoke earlier about some successful engagements we've had with emergency management. When we have hurricanes hit anywhere in the U.S., NOAA, so I guess for the non-U.S. listeners, NOAA is the National Oceanographic and Atmospheric Administration or agency. I might have flipped those two. But anyway, they do some amazing things. They provide just a ton of really, really fantastic data. And one of the most amazing things that they do is that after a large hurricane, they will fly the affected area with aircraft and generate high resolution imagery for use in understanding sort of the after effects of that particular storm. It's incredible. I mean, they do it really, really quickly, and they put that data up for anybody to use. That's where you sort of get into a bit of a sticky wicket, because you've got this just massive amount of publicly available imagery data that you can do a lot with. And what ends up happening a lot is that people look at it with their eyes, which is totally okay, but that is not a way to scale. And a lot of times you're under the clock, right? This is a disaster response. So with something like Tesseract, we're able to, let's say, NOAA flies that imagery collection set of flights. They put these high resolution images inside of an Amazon or an AWS S3 bucket. I think the last time we did this, it was something like 50,000 images. We're talking terabytes of images. We're able to take a off-the-shelf model to do things like see where roads are impassable because there's debris or flooding. We're able to take another off-the-shelf building damage assessment model to see where. So these are pre-trained models.
Buildings.
Yeah.
I'd like to flag that for a subsequent question, but yeah, just round out the buildings.
You got some buildings behind you.
I do, certainly. Yeah. This is Atlanta.
I was gonna see if I could recognize it, but I
didn't. Sorry. Okay, sure. There's a huge highway in the middle. I think there's a big black spot.
There's a big black spot, yeah.
Yeah.
Yeah, that's classified as road.
Right.
And so what we're able to do is take those images, connect out to that bucket, take an off-the-shelf, in this case, 2 off-the-shelf machine learning models that are pre-trained to recognize A, where roads are impassable, or B, where there are damaged buildings, and run both of those models at scale. Probably, I think the first one took like maybe 40 minutes to run. Let's say they were both in that ballpark. On 50,000 images, get a result as a new data set inside of entanglement that essentially displays where buildings are damaged or where roads are impassable. Generate a web token from that, shared out to an ArcGIS Online dashboard for public consumption. I mean, we're talking from start to finish, maybe like 2 hours to do that entire thing.
Yeah.
So just sort of incredible, and that's heavy lift, right?
Yeah.
That's a big thing to do, but the really important takeaway there, I think, is that it follows the same workflow as anything else we would do in our platform. You're just scaling up the workers that you need to do that, like the GPUs that you need. And so scale is built in from the beginning. That's a really important point.
That's amazing. So this is perfect then. for why I then came to you. So there's an interesting sort of sequence here. Johnny Harris released his video after his brave efforts and the time investment and all of that to actually go to the desert in Saudi Arabia. Then that was around about the time that I was recording this episode with Jordan Regine about all of the work he did with Bing Maps and creating 70 3D cities and 40 cities worth of street sites and a lot of elevation data that he was working with. Then he was the one that actually saw your post on LinkedIn, which related to a question I had in the episode I did with him about the impacts on, I guess, more vulnerable communities around this very long linear city that's been built in Saudi. And so then I sort of came to you about, I guess, using the terminology you've just been giving us about geodesic, how Tesseract might be used to, in your case, what you're talking about is building damage, but nevertheless, you have an analytical process which can detect change with building footprints. Am I right?
Yeah, that's
Okay.
correct.
Yeah.
Yeah, well, I'll stop there. Yes.
Yeah, so then I asked you if you could go back a bit further in time to look at what the BBC said was around 2020, something like that, and what the Google Earth engine imagery says is there's this time period between sort of 2020 and 2021 where it appears, at least in Sharma, this village nearby or just in the general Neom development, which was cleared out. And, you know, this issue needs to be treated with some sensitivity. Naturally, where there are large projects that a national government may undertake to, in a general sense, uplift the economy and create a brighter future for its people, it needs to be acknowledged that unfortunately, some difficult decisions may need to be made. Nevertheless, one might hope that those decisions shouldn't be accompanied by ending someone's life or having to stoop to such a level of coercion as putting a dissenter on death row. So, you know, this is not to say that you are endorsing one thing or the other or to box you into a corner at all. I'm just trying to provide the context for why I came to you to see what our discipline could offer in terms of insight or to accompany the points that the BBC has been making about how perhaps more vulnerable communities have experienced this project. So I think you did try to look at what Tesseract or the analytical processes that you can bring to bear revealed about these communities. Was there any insight that you gained?
Yeah, and you know, I just think you're spot on with this, and it's not boxing me or us into a corner at all. I mean, a lot of us came to the company because we want to do good. It is a very strong stance that we have that's, you know, written into a lot of our contracts, what we will and will not allow our software to be used for. And really, it's quite something to be able to use software to impact things positively on the ground. Our first sort of taste of that was this building damage assessment that we were able to speed up incredibly from Hurricane Milton. And that is a really particular feeling to be able to look at your software and say, oh, this helped a thing. That doesn't happen very often. So it's anytime we get an opportunity to do that, it's fantastic. And, you know, from the domain side, we don't always know what to shine a light on, right? So that's where the community comes in. To get to the specifics of Sharma, so you asked me to extend the time period and extend the bounding box, which when I got that message from you, I just went and redid that. Right, it did not take long at all. But then but I didn't get the results that I wanted. So I looked at that the next morning, and this will be a good distinction between sort of the building damage assessment model and ACD, which is what we were using for the initial interrogation of the line. ACD requires as an input the synthetic aperture radar data, and so that's what I was using as input to look at that second set of analysis you wanted me to do. The building damage assessment uses RGB, red, green, blue visual spectrum data of a particular resolution. And so that's something that we haven't explored yet. When you are, so back to ACD, when you're conducting that, you're essentially looking at image one, scene one, as it's called in the parlance, and scene two, and you're comparing the differences. If scene one or scene two or both have bad data, have some sort of wonkiness to it, your ACD isn't going to be meaningful at all because it's comparing, it's garbage in, garbage out. And so when I ran ACD, animated through times to see what was happening, I would sort of get the same thing that we looked at for the line. So polygons of change, and then a big, let's call it like, think of like when you watch TV as a kid and you'd get a signal, your signal fried
Noise.
for a bit, and you get the wavy line. So it'd be like polygon, 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 noise, polygon, 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 noise. And so we got that sort of several times. So as a video, it looks a mess. What that noise is radio frequency interference of some kind or another is what we came up with. We sort of just looked at it and said, from the signature, it looks like radio interference. And it makes sense if you've got this satellite signal. So SAR doesn't take. SAR is not what's called a passive sensor. So it doesn't just take reflected light. It sends out an active signal and then collects it on the next pass. So it's sending a signal up from space from many miles up. It's like signal has to go through a lot of stuff, and if it hits radio interference or something else, it doesn't necessarily have the correct wavelength to penetrate through that, and so you get this weird image. We really couldn't say anything more than that.
Do you know when it happened? Are you able to tell us which months? So is it once a month you get an image from ESA?
I'd have to go back and look. So we took the analysis back to 2020, so 2020 to 2024, and I'd say maybe it was about 20-30% of that sort of progression was.
But it's really interesting to see that there was no such interference for the whole year 2023 that you did the analysis up to now. So there's 2 years you didn't have that issue. But in the prior years, it's interesting that you are reporting to us. I mean, so we already discovered the concepts of spoofing and things like that in the positioning, navigation, and timing episode with Eldar. Honestly, this is just reminding me of these kinds of radio interference that can mess with positioning systems. But you're saying it can also interfere with at least radar-based imaging approaches.
Yeah, certainly. And this is where I sort of have to extend the caveat that this is not my area of expertise, right? So I can't say, sitting here, whether it was spoofing, whether something was purposeful or not. I just don't know. All I'm really saying is interfered images. Now, ESA puts out, I think I sent you that link, ESA puts out a great map of where there is RFID interference.
RF interference,
Yeah, thank you, RF interference. But I don't know that it's over time. I think it's sort of like for active passes of Sentinel.
I'm fascinated because we know from the BBC's reporting that the military was sent to these areas to, it's not the nicest term, but to clear out these villages of the order. The reporting says that of the order of 20,000 people in the end were evicted and relocated, returning to some of the concepts that I came across at the beginning of my career. And I should say that, a part of the motivation for me is that I gave up a lucrative oil and gas geospatial career. I was on a Santos project doubling the size of a gas field. I gave that up. I could have been a fly in, fly out worker, 20 days on, 10 days off, $130,000 a year in 2011, less than a year of experience out of college. and instead I went volunteering on this, NGO project, advocating on behalf of those in urban poor communities in an eviction and relocation context. And then here I was coming across in my professional career, 14 years later, the same sort of a conflict, of values. And I wanted it to be in my life that I didn't abandon my commitment to where I can. What can I say? Not leveraging my privilege at the expense of the disadvantaged. So that's
well
the
said.
motivator. Yeah. And it's the risk of sounding cliched here. What's occurring here is a discussion between two men who enjoy privilege. You're in Houston enjoying the free world. I've recently actually won the green card lottery and can also enjoy life in the free world. It, in my view, offers the best image of the world that we describe as free, that we, when the opportunity arises, use our privilege to advantage those who don't enjoy the freedom that we have, if I can put it that way. That's all I'm trying to do here.
Yeah.
And these results are interesting. So did you see, I mean, because you can just by eye go through, month by month or year by year in Google Earth Engine, the RGB imagery. Did you get, so you said 30% of it was noise, but what is not noise? Perhaps change could be detected?
Yeah, oh, certainly. Yeah. There's a lot of, you essentially see a version of the same thing on that. It's not really a peninsula, but it's a piece of land that juts out. That Sharma's on. You essentially see a version of that same thing that you saw with the line.
Okay,
you see
so you did detect some change.
of construction. So yeah, for sure.
And we do know,
and you can tell where there is so just on like my brief sort of looking into it, right? You can tell where there's I guess it's a palace of some sort that's being constructed.
That was one of the first things that was built on the coast, was a palace, of course.
Yep. And there's, you always lead with a palace. And then there's really construction really all around. So there's no lead up. So starting in 2020, it's just starting in 2020, there's activity
everywhere.
And then, the first set of noise, my first thought was, I wonder if that's a sandstorm or something like that.
They happen.
Yep.
So that's temporal data, and you mentioned the seasons, and that when you start looking at temporal data, you can look at the weather. So that's bringing in exactly what you're saying.
Oh yeah, exactly.
Because sandstorms there are horrific sometimes. Yeah. Okay.
Yeah. But so what we can do, so this is a good example of just like a first pass analysis. Here is what I'm seeing, right? And I don't know anything else other than that. But then what you can start to do is and I'll caveat this, that I know that there are some ways to sort of like dig deeper into sort of like where the signal's coming from. I think we have some people in-house that are much more expert at that than I am. However, what I do have a decent amount of experience in is sort of using data to get data about that data. Because one of the first things that I would be interested in doing and understanding if what I'm seeing is an aberration is to look at it statistically. And so then you can then your sample space and your sample geographic space and temporal space becomes this idea of seeing a lot of interference here. Is that to be expected for this particular time period in this particular area relative to other time periods in area? Am I seeing something more or less above average here than I normally would? And just from a personal level, that's how I would start going about that. Running that same set of analysis in lots of other places and seeing if what I'm seeing is a statistical aberration or not.
Right.
There's more direct, again, I know there's more direct ways to get at what that interference is. I'm just not expert in them.
Okay. All right. So I think we're at the point where we can say that perhaps unexpectedly, a company like SeerAI with its geodesic spatiotemporal analytical platform can actually offer something to some journalists of relatively high-profile organizations like Rory Jones, who works for the Wall Street Journal. He's done a lot of reporting along with Elliot, I've forgotten his surname, on activities on the line. Merlin was the journalist who was responsible for one of the most high impact pieces for the BBC, including interviewing this former Saudi army colonel who was invited to the Saudi embassy after exiling himself in the UK. He was invited by Saudi officials to visit their embassy. I'm sure you can understand the implication that I am making here.
Interesting.
Given to what happened to another Saudi national who went to another Saudi embassy in a different country. So yeah, Merlin, I'm just sort of listing off some perhaps unexpected though valid clients for the kind of, for what SeerAI can do, along with Johnny Harris. And it sounds like within about 2 hours of work, you can begin to provide insight that could provide an important extra level of detail accompanying the stories that they're trying to tell. So again, this episode has been hugely useful, I think, for the untapped resource currently. In my view, there are industry constitutes for the storytelling that these organizations are trying to offer the public.
Yeah, I think that's a fantastic example of what we could be doing. And I think in pointing that out, you really underscore an important point of, I don't know, let's call it AI or analytics generally, and what we think of as a successful engagement specifically, is that anything we do, I think to have the successful outcome that you want, you have to pair it with some sort of, for want of a better term, subject matter expertise, or somebody who understands the narrative of the domain that you're in. So it's not, you cannot just rest on top of a technological solution.
Yeah, right. There needs to be some meaning.
There has to be meaning, context, guidance, iteration. Yeah, you have to have that to have a successful outcome.
Okay, so maybe then just to extend an idea raised at the end of the last episode with Jordan, because I've also had Whereabouts on the show. I actually had a beer with Mo Sawat, the CEO of Whereabouts in San Francisco, the middle of this year when I went over to a conference. Or a meetup at least. So amazing bunch of guys. Will Lyon was the guest. He's moved on to another organization, but I really appreciated the patience that Will had to explain all the concepts behind Whereabouts. So the idea I have is that, about a service that our profession could offer these publications or news organizations, but just humanity more broadly, is some sort of a monitoring service that just continually ingests the latest imagery from Sentinel, continually runs a defensible analytical process on it to provide an ongoing animation of change detection. In the bounding boxes of tribal communities, yes, around Tabuk province, but also it springs to mind, why not the whole world? How costly would it be to maintain that kind of a continual analytical process that the likes of these journalists can just constantly, regularly check in with to see? Because in a way, this kind of a platform could tell stories.
Yeah, and that's
the kind of stories you would hope.
That's what I want to do. That's
the kind of stories that you would hope that us, as people of privilege, would be able to tell and would want to tell.
Yeah, yeah.
Jordan's thought was that platform would be incredibly expensive.
I don't, for the entire globe, there are issues with the data output from ACD, from any type of data. So this is, again, this is where the idea of an analytic solution answers a specific question.
Yeah, I think where you might be going is that ACD would just tell you where things are changing. You wouldn't know what kind
False
of change it is.
positives.
So if
A lot
maybe
of
there's some
potential,
UN age,
yeah.
yes, exactly, a lot of false positive. But I agree, and you introduced the important issue of noise. So yeah, lots of uncertainty. But maybe then I could contribute the extra. If I could clarify things a bit, by perhaps there's a UN agency that's responsible for, I don't know, maintaining a set of bounding boxes, if I can use our language,
Yeah.
of maybe the world's top 100 most vulnerable tribal communities that, by the way, also have a multi-thousand-year connection to that land and would be good for humanity, that it wasn't expunged too readily.
Yeah.
So if I
Yeah.
gave you those 100 bounding boxes that were spread amongst the Amazon, Tabuk province, a few Central Australian Aboriginal communities, we talked about Papua New Guinea. There are several. There are some of the most ancient indigenous civilizations there that offer a lot of insight if you understand how they do things about human history. So if I gave you those 100 bounding boxes, how expensive would it be for, if the BBC, the Wall Street Journal, Johnny Harris paid a subscription to maintain that platform? Do you have any idea? We're talking hundreds of thousands per year of dollars.
Probably surprisingly low. Really, what we're talking about is compute costs, and that's kind of it. And it's not a ton of compute to do, especially for a particular, a smaller bounding box that's not over, well, a lot of this data doesn't go back that far, so you can't make it go back too far. But while I don't have an exact cost for you, I know that it's probably not cost prohibitive. And the reason is because the process that we're working on top of is, again, there's scale built in from the beginning. So you're kind of just talking about spooling up more GPU workers if you've got more areas to look at. There's obviously, I don't want to oversell it. There's obviously technical things to consider. How many dashboards are you serving out? What is, once that's outside of our bailiwick, right? We're not making the dashboards, we're using other people's stuff. What does that look like? So there's like usability issues.
Yeah.
Generating the information itself, not difficult and not expensive. But where I think it would be valuable is, and this might actually help with sort of like the general education piece of geospatial, because like, wouldn't it be really neat if you get this idea of a very complicated mechanism of data acquisition and processing, which, I mean, people get PhDs in synthetic aperture radar data analysis. I mean, it is a crazy complex field, but something like that, but then represented as something that the general public can consume as sort of like spikes in activity, right? They're just flags.
It could be alerts.
Yeah, but that's like, when we talk about how we think of using our platform on data, it's really this data integration piece. It's saying that ACD is one thing. And maybe that's what I'm trying to get across. There's no like silver bullet. ACD is one thing. It's one way to look at the world, and maybe that can offer you a flag, a hand raised that says, "Look over here." Then you pair that with other data. Maybe you can pair that again with like
social media reports.
Social media reports, Beer's night fire data, or
right.
Actually, the name of the data set. You could pair it with, I don't know, this probably wouldn't work in tribal areas, but we've connected out to things with like, I don't know if you've heard of encountered iNaturalist.
No.
iNaturalist is a really cool app for your phone where people go around. They love being out in nature. They record plants and animals that they see, types of trees, specific species. They've got millions of users, and all of a sudden you have this huge database of where things are located. From that, we can easily connect out to that and get animations or time series of bird migrations or ebbs and flows in different species. And how is that connected to movements and patterns of people, right? So that's the integration piece we're talking about.
Yeah, and we also know, again, from the PNT episode with Eldar or Frontier SI, that radio frequency changes and the density of activity there is also another source of information about change.
Yeah. Yeah. Integrating sources of information.
Communications-based radar radio frequency rather than what you're talking about, which is for deriving an image from radar returns.
Yeah.
But yeah, to use another sort of cliche term, data fusion, I guess is the point.
And we have used the tagline of the world's first and only spatial temporal data fusion platform. That is a mouthful.
No, I love it.
But it's also accurate.
I've just got the tagline for the Substack post for the episode. Okay.
That's fantastic.
Amazing, Alex. Well, you're beginning to, and the industry is beginning to help allay my fears that our privilege may be associated with unfortunate outcomes for those who don't have as much power as us sitting in Atlanta or Houston and enjoying a free life. So you're helping to address a fear I have, Alex. So yeah, thanks for coming on. Last question. If you were to hire an apprentice, what qualities would get them the job?
I'm actually thinking of somebody specifically that I work with regularly, who's been with us for a couple of years, but we got him out of college. He's also very young, which I guess I tend to think of an apprentice as, but it doesn't have to be.
Hey, I'm 41 years old. I'll put my hand up.
Hey, yeah, me too, man. Right? Like, I don't even know what old and young is anymore. But I think a couple of qualities. One is really good lateral thinker. That conversation that you and I just had, you have to be able to have over and over and over again, because that is the space that we're in. We're not domain experts. We're not trying to solve a particular niche problem. We are trying to literally reach across different data sources, different data domains, and different potential solution spaces. That's a complex space to play in. It's super fun if you enjoy it, but you got to be a lateral thinker. You got to make those connections. That's the first thing. With that goes a large component of curiosity. So we tend to attract people that sort of like that first push of data scientists, which was like, I was in a particular technical domain, but I'm interested a lot about the rest of the world. And I realized that a lot of it's just data and information. Awesome. You would fit in great here. Another one is the ability to sort of play therapist to potential customers internally and externally. You have to be able to ask questions and get at the root of the problem that they're trying to solve. We're not always successful at that. I'm not always successful at that. It's a hard job to do, and sometimes prior knowledge, prior experience, or ego can take over. And you have to push all of that down and realize that you're playing therapist for the customer. You're trying to help them.
This also links back to what you touched on when I asked about detecting customer needs, that no customer is superior to another. Regardless of the complexity of their problem, they are still valid.
Yep. How many of us have seen somebody fumble with something that we think of as a trivial piece of technology and said something pejorative about it? I mean, that's the attitude you can't have, and it's so easy to have when you're in this space. And
in fact, it's those customers that are probably the most frequent. And if you can catch as many of them, the more of them that you can catch, well, that's really the big market.
Yeah.
So
yeah, I agree with you, because you're getting them fresh. They're not having to unlearn something, which can be pretty difficult.
Right.
For an ideal apprentice, there's certainly a technical piece that you have to have. This is a very technical field and we do technical work. However, you don't have to split the atom. That's not where the successful solutions come from. You have to be able to do all the things, but you know, in oil and gas, I found a lot that the ability of sort of like the data science group to come up with a technical, hyper accurate model, let's say, oftentimes exceeded the ability of the downstream customer to fully consume, apply, appreciate those results. And it didn't have to do with any sort of unwillingness of that customer. And it certainly didn't have to do with the technical aptitude of that customer. It had to do with sort of like gaps in understanding knowledge, what problem was really needing to be addressed, and also how they needed to address it. Like, do people need to talk to sort of like multi-skilled operators in the field to do XYZ? If that's the case, a 70 parameter, you know, deep learning model might not scratch the itch. It might not, even if your accuracy is better, might not scratch the itch. So that's where you have to be technical enough, but you don't have to be splitting the atom.
Yeah.
And the last piece might be a little surprising. And I don't know if this is totally, I'm not sure if I'm completely sold on this yet or not, but I'm leaning more towards the idea of not being an expert or even having much of a background in geospatial. And it's because we've got enough of that in-house. We don't need to bias our own thoughts anymore. And we need people who see the world in a way that we don't see it.
Yeah.
So if those types of people, if we get those types of people that can see geospatial application that we can't see, if they understand it from basic principles differently than we do, that's fantastic.
I can think to me, not to bang on about this too much, but a journalist is in a way definitely not what one would think of as a hugely technical software developer, physicist type person, but nevertheless is strongly in touch with current events in the world and is forced to know about and be up to date on the most meaningful ones to sell news. So yeah.
Yeah. And the lateral thinking piece is certainly there, right? And the empathy and understanding people's perspective. That's a huge part of it. Sometimes it's generally as a field, I think we don't listen enough, which is kind of what I was getting at the beginning of sort of segregating ourselves in a geospatial corner. I don't think that works well. I don't think it works for the outcomes that we want as the geospatial community. I think we want to be more involved in the larger conversation and have geospatial be a part of that, not just the we're special, we do geospatial part of the conversation.
Okay, I think that's an excellent place to leave things. Alex, you are proposing the dissolution of the discipline of geospatial. Let's do it.
Oh man, is that going to be the tagline? That might get us into a little bit of trouble.
That's exactly what I want. I'm seeking trouble. Come on.
Yeah, maybe we need to do that. We need to. You know what we do? We need.
Come on, it's the end of the year, man. We need to like
bring geospatial into the fold. Like let's actually integrate. Let's be part of the conversation. Right.
No. I still like the idea of just removing the discipline.
Totally dissolve. All right, let's do it.
That's going to piss off the most people.
Let's pull the pin. Let's do it.
Perfect. Well, I think this will be the last episode that I'm going to record and probably publish. So yeah, it's been a fitting conclusion, I think, to bring time into things and really start talking about visualizations that regular people have more of a visceral feeling and understanding of. So Alex, you've been a great guide.
Really appreciate the questions. The conversation was fantastic. If you do find yourself in Houston, don't hesitate and I'll buy your next beer. Luckily, we're a company spread out amongst 14 of us across all the time zones of the US. So if you're in the States, you probably got your pick.
All right, I'll go on tour. Sounds great.